Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of area of composite figures. This is standard 7.9C in the great state of Texas, and we are using item number 6 of the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have this composite figure. Looks like it's two rectangles and a right triangle, and we need to simply find its area. All right, so in case we need it, we've always got our reference chart up there. And since we're dealing with two different types of area, let's look up here. You'll see them towards the top of the screen. So the triangle is going to be 1/2 base times height, and then my rectangle is going to be base times height. So it's always easy to kind of remember that the triangle is half of a rectangle, because you can take any rectangle, any quadrilateral for that matter, and turn it into two equal triangles. So you just take that and you cut it in half and you're good to go. All right, so let's simply do this. Let me scroll that down a little bit so I can see my four options. And I just want to find the area of each of these and just add them up. That's what we do when we have composite figures. So I'm going to do area equals, this is my base times height. This is going to be my base times height. And I'll change my color here. And I'm going to say 1/2 base times height, because my triangle is going to be a slightly different one. So let's start with my two different rectangles, right? So I've got my 30 and my 8. So 30 times 8, that's going to get me a 24. I'm going to put that over here so I can stack them up and go ahead and just add them. 24 with that extra 0, because that's what we do when we multiply by multiples of 10, 100, 1,000. We just multiply the digits that are not 0. 8 times 3 is 24, and then add the number of zeros at the end. So I've got 240 square centimeters. That's pretty easy. 240. Let's do this other one. I've got the 6 times 12. All right, so 12 times 6. And that's just a basic fact, right? 72. Let's make sure I line them up. Square centimeters. All right, 72. Now, the only quote-unquote trick in this problem is my triangle. Well, first off, it's a different formula. It's 1/2 base times height. And secondly, it looks as if I don't have any measurements at all. But it is a right triangle. So what does that tell me? So when it says it's a right triangle, and I also know it's a right triangle because it's got the square right there in one of its angles, that means that a side equals a height. So one side equals my height. Because in normal triangles, right, you're going to see something like this. If you see a triangle like this, you can't use any of the sides as the height. And what you would end up needing to do is they would end up giving you like a dotted line like this to show you what the height is, because you can't use one of the sides. But since it is a right triangle, you can actually use this side right here as the height. So if I know that side, I know my height. Well, if this side right here of the rectangle is 8, then that is also 8. Okay, so it's going to be 1/2. My height is 8. Need to figure out the base. Well, seeing as how this side right here is 6, then I can say that base is 6. So that's it. All we got to do is just take the height and the base of these two rectangles and use them as the height and base of this triangle. And so that's going to be 6. Right? So how do we want to do that? Well, you can either multiply 1/2 times 6 to begin with, right, and say that's 3 times 4. So that's 3 times 6, and that's going to make that 3 times 8 is 24. Many different ways to do that, right? Or you can do 6 times 8 is 48. Half of 48 is 24. You can even do the half times 8 gets you 4. 4 times 6 is 24. Many different ways to do that. They all end up with 24. So that's 6. That's going to be 1113. 336 square centimeters. The answer is A.